Okay, so let's move on to the next data set. And we already took a look at the mental health in the IT professions. And the only other thing you might want to do is toss up a bar plot for some of these lists. You can use nlargest there as well. And then after that, we have the iris data. So let's go ahead and reload the iris data. And all we've done so far is to convert the type of the species column to be category. And so we have some info there. Now I can also go ahead and do iris df sub species and then use the cat method accessor. So that's going to give me some category related methods. And I'm just going to use categories, which is just a property. And so what that shows me is the list of the categories that are available. And let's go ahead and do some plotting. So what we want to do with the iris data is basically we have the species for the type of iris, and there's 3 different species tracked. And then we have some measurements about actual flowers. And typically this is used as a machine learning example to show how to build a system that can classify new flowers into the correct species. And most of building a classifier has to do with learning rules based on these measurements. And so we're just going to explore the measurements a little bit. So what we want to see basically is how differences in these dimensions affect the classification. And so for something like that, a scatter plot is a good start because that will give you each of these flowers will be a single point on a scatter plot on 2 dimensions. Pick any 2 dimensions, plot a point on it, and then you can show what species the point is by using different colors or different shapes for the markers. So let's go ahead and toss up a scatter plot really quickly. And there is a plot method on the data frame with a scatter method that you can call, but it's not quite doing what I want it to do for now. So I'm just going to drop down to actually using the matplotlib interface directly for this part. So I have matplotlib.pyplot is imported as plt. And I can say plt.scatter. And then I give it an x dimension, which is a series of data values for an x coordinate, and a y dimension, which is a series of values for y coordinate, and then it will plot those. So I'm just going to pick the first 2 that I see, sepal length and sepal width. So let's go ahead and plot iris data frame sepal length on X and iris data frame sub sepal width on Y. And here's my plot. So this is showing all of the irises on X and Y dimension. And then I can just adjust some of the characteristics here, like I can make this bigger, which I think is going to be useful. So to make it bigger, what I do is I go plot.figure, and that adjusts the whole figure that this thing's drawn on. The graph is drawn on a figure. And then I can set the figure size, is it fig size? Fig size to, let's say, 10 inches by 6 inches, and the DPI to be 96 DPI. Okay, so same data, just a slightly bigger graph. And then I find these markers to be a little bit big, so maybe I want to do size equals, let's say, 3. It's not size, it's probably just S. Yeah. 3's maybe a little small. Let's try 5. Okay. Now, what I want to see, though, is different colors or different markers for each of the different species. So what I have to do basically, there's a couple of ways of doing that, but what I'm going to do is plot 3 separate groups. So the first group is going to be all of the setosas, and then the second group I plot is going to be the versicolors, and the third group is going to be the virginicas. And I could just hard code those, right? So basically I can do this. I can say like species is equal to iris data frame sub, and then iris data frame sub species equals setosa. So that's going to be all of the rows that have setosas in them. And then plot species instead of iris df. So this is going to plot only the setosas, and there they are. And then I could repeat that. I could do species is iris df, subspecies equals versicolor, and then plot those, and then virginica and plot those, and they will go on the same graph, but it cycles through the colors. So the next one would be orange, and so on. So let me go ahead and do that for virginica. So species is virginica. So there's the setosas in blue and the virginicas in orange. And I could do the same thing for versicolor as well. But a more general way of doing the same thing is to use a for loop. So I can say for cat in iris df sub species dot cat dot categories. So here is once again a method accessor for categorical values, and this produces the list of categories, and I can iterate through that. And then here for this line, I'm just going to pick off the ones that match the current category and plot them. And then this will work no matter how many different categories I have. So here are the setosas, and then the versicolors are actually, I think the green ones are the versicolors, and actually no, the orange ones are the versicolors and the green ones are the virginicas. Okay, so what does this tell me if I'm looking at it? Well, think in terms of, with these 2 dimensions, you could draw a line basically to split off one set of flowers from the other. So like if I drew this line here, it would do a really good job at classifying anything on this side of the line is a setosa, and anything on this side of the line is either a virginica or a versicolor. So that line right there. But then if it is on this side of the line, this doesn't really help me very much because I can't really tell. There are no lines that I can draw that are going to separate the virginicas from the versicolors. So it's easy to learn part of it based on this, but not the whole thing. So let's go ahead and not look at sepal length and sepal width. Let's look at 2 other dimensions. So let me go ahead and copy this again. And let me see what I get with petal length and petal width. So petal length and petal width. And then on this set, on these 2 characteristics, well, we see that not only this line right here does a really good job at separating the setosas from the versicolors and virginicas, but this line right here does a pretty good job, not perfect, but pretty good at separating the versicolors and the virginicas. So how would I actually draw that line and sort of visualize what effect it would have? Well, what I'm going to do, is I'm going to sort of calculate what this line would be and then sort of like rotate the whole thing around. So basically, this goes from, let's see, this goes up to this point right here. That's somewhere around um, 4 3/4 or 5, and somewhere around on pedal length, and somewhere around 1.5 or a little bit more on pedal width. So what I want to calculate is basically 4 times that plus this. Or actually, let me say 5 over 1.5. So maybe 3 times the pedal width plus the pedal length. And I'm going to plot that. So let me do df. Actually, let me put this in a new box. So first I'm going to add a new dimension to my iris data. And let's call that pedal sum. And it's going to be equal to 3 times iris df sub pedal width plus iris df sub pedal length. And let me go ahead and plot all 3 pieces of information, and I'm going to keep the pedal width on the y dimension, but instead of plotting pedal length, I'm going to plot pedal sum. And hopefully the split between the flowers will be more of a vertical line. So I'm looking for it to be as close to a vertical line as possible. Okay, so this one's easy. This vertical line works pretty well to separate these two. And then this one, I'm going to draw a vertical line maybe right there. Yeah, a vertical line right there seems like it would separate it pretty well. And that would be my classifier. So now here's, I'm just, basically I would say something like if pedal sum, species of pedal sum for a new row, if species of pedal sum is less than 5, then it's a setosa. Otherwise, if it's less than, let's say, 8.5, 9.5, if it's less than 9.5, then we're going to classify it as a versicolor. Otherwise, we'll classify it as a virginica. Now, the other way that I can display this is as a histogram. Once again, just like I looked at a histogram before for the distribution of salaries, I can do the same kind of thing with this flower data. So let's go ahead, and what I want to do is same kind of thing. I'll say plot dot figure fig size is, say, 10 by 6, and DPI is 96 DPI. And then I'm going to do the same loop as before. So for cat in iris df subspecies dot cat categories. I want to go ahead and get the irises for that category. So species is iris df sub iris df sub species, is equal to category. And then I could just plot it on a histogram. So we're going to plot the petal sum on a histogram. So plot.hist irisdf sub petal sum, and let's see what that looks like. Did I not call it petal sum? Yeah, I didn't have an underscore in it. I used that. Okay, so there's my plot with all the data, but I actually want I want different colors for each of these things here. So really what I want to do is I want to add all three of these sets of data into a list and then plot the distribution of that list. So what I'm going to do is make species samples is going to be an empty list. And then instead of doing the plot here, I'm going to say species samples dot append species. Oh, I didn't plot species before. That was a mistake here. That should have been species. There we go. Okay. So there's the three separate colors that I was looking for. So this is almost what I want. And the one problem is it's actually drawing each of these species on top of what's already there. And so in particular, this little bit here, there's an overlap between the orange values and the green values. But since I draw the green values after the orange values, they get covered up. And if I want to not cover up the orange values here, what I have to do is draw everything all at the same time and specify stacked as well. So stacked will stack these values on top of what's there. Well, you'll see what I mean. So bottom line is that this doesn't quite do what I want. And if I want to draw them all at once, and then here, instead of plotting the values, what I'm going to do is I'm going to append species samples dot append species sub petal sum. So that's going to add this set of samples for this species to my list of samples. And then after I'm done, I can plot that whole thing. So plot.hist species samples. And then I can specify stacked as true. Okay. So this is what I meant before about stacking them. See, instead of covering the orange values up with the green values, it starts drawing them with the bottom of the green values equal to the top of the orange values. And same thing here. So the top of the orange values is the bottom of the green values. And so you can see, once again, the split right around 10 is probably about the right place to draw that. And then the split right around, say, 4.5 is probably the best place to draw that. And then just as before, if I want to refine these splits a little bit more, I can change the number of bins. So let me go ahead and basically double the number of bins here. So let's say bins is 20. Oh, bins is 20. And actually, it's still looking like somewhere around a little less than 10. is a good place. Let's do 40, see if that's helpful. Yeah, I think that's about as good as I need to get right here. I'm just going to call that, so 9 is right there, 9.75, and this is somewhere like 9.8, 9.75 is probably about right.